The Honorable Rector of Universitas Diponegoro, Professor Yos Johan Utama, Vice Rector of Academic and Student Affairs, Professor Budi Setiono, Vice Rector of Resources, Professor Heru Susanto, Vice Rector of Communication and Business, Dr. Dwi Cahyo Utomo, Vice Rector of Research and Innovation, Professor Amba Rianto, Dean of Faculty in Universitas Diponegoro. We'd also like to recognize and welcome the Chairperson of ICENIS 2021, Professor Triratnaningsi Suprabawati, Vice Chairperson of ICENIS 2021, Dr. Thomas Triadi Putranto, all organizers of ICENIS 2021. Good morning, selamat pagi, Bapak dan Ibu sekalian. The Honorable Keynote Speakers and Moderator, Professor Wiku Adisasmita, Professor Arif Satria, Professor Laksmi Dewanti, Professor Budi Warsito, at School of Postgraduate Studies, Professor Peter Jal, good morning, sir. Professor Madaliko, Professor Fatimah Yusuf, Professor Robert Peacock, Professor Sitaraman Faidianatan, Professor Elko van Berg, and our moderator, Professor Sudarto Hadi. Good morning, sir and ma'am.
Good morning.
And
good morning.
And all excellencies and distinguished participants.
Excellencies and distinguished participants, delegates, ladies and gentlemen, my name is Gendis and I'm with my partner, Jeha, would be leading the special occasion. We're glad to receive all of you here. Good morning and welcome to the 6th International Conference on Energy, Environment, Epidemiology, and Information System, ICENIS 2021. Before starting our conference, allow me to inform you about the agenda. ICENIS is a two-day conference. After the opening, we will pay our respect to Indonesia's national anthem, Indonesia Raya, followed by welcoming remarks from ICENIS Chairperson, the Dean of School of Postgraduate of Universitas Diponegoro or the representative, and we will be opened by the Rector of Universitas Diponegoro or the representative. To follow, we will have our plenary sessions and discussions. There will be 4 parallel sessions in this conference, and each day has 2 sessions. And for day 2, after the 3rd and 4th parallel sessions, there will be a closing ceremony.
Ladies and gentlemen, for these 2 days, this occasion will provide you plenty of knowledge and opportunities to discuss about the impacts of COVID-19 pandemic on water, environment, energy, information system, and strategies for the adaptation and mitigation, as it is mentioned for this year's theme. Furthermore, we know that it's been an annual event. My partner Gendis would like to tell you more.
Yes, that's right, Cheha. ICENIS is spearheaded by the School of Postgraduate Studies of Universitas Diponegoro. As we all know, Universitas Diponegoro is one of the leading universities in the country. The first ICENIS was held in 2016, and since then, ICENIS has been organized annually. All accepted articles of the first through 5th ICENIS have been published in Advanced Science Letters. As for our 6th ICENIS, selected papers to be published in E3S Web of Conference.
To begin this occasion, ladies and gentlemen, may I request you to rise and remain listening to the national anthem of Indonesia, Indonesia Raya.
Please be seated. And now we will hear a welcoming speech from the ICENIS 2021 Chairperson, Professor Tri Retnaningsih Suprabhawati. Prof, the time is yours.
Thank you, Candice. Assalamualaikum warahmatullahi wabarakatuh. Your
Waalaikumsalam warahmatullahi wabarakatuh.
Rector that represented by Vice Rector for Research and Innovation, Universitas Diponegoro, Prof. Ambarianto. All Vice Rectors that are able to join with us today. All of the Deans from Undip, and then Dean and Vice Dean of SPS, keynote speakers, moderators, Prof. Sudarto PH and Prof. Purwanto, Head of Study Program at SPS, Head of Reputation Office, Prof. Denny, and then Head of PPP, Prof. Purwanto, all participants, ladies and gentlemen. On behalf of the ICENIS 2021 Organizing Committee, I'm honored and delighted to welcome you to the 6th International Conference on Energy, Environment, Epidemiology, and Information Systems, with the themes, the impacts of COVID-19 pandemic on water, environment, energy, epidemiology, information systems, and strategies for their adaptations and mitigations. This conference is expected to design an interactive international forum to provide a platform for sharing and exchange information on the latest research on energy, environment, epidemiology, and information system. Although the current situation is uncertain due to the pandemic COVID-19, however, our conference is rich and varied with 10 keynote speakers that come from 5 continents: Africa, America, Australia, Asia, and Europe. I hope to report that the enthusiasms of participants are very high. There are more than 500 registered, and we accepted 430 research articles, which will be presented via online conference within 14 parallel oral sessions each day. The participants come from various countries, such as Japan, Czech, Algeria, Sudan, Uganda, Malaysia, Tanzania, Timor-Leste, West Africa, Turkey, Uzbekistan, Taiwan, UK, and United States, and from all over Indonesia, consisting of researchers, lecturers, practitioners, post and undergraduate students, belong to various institutions from Java, such as Universitas Indonesia, Institut Teknologi 10 November Surabaya, Institut Teknologi Bandung, Universitas 11 Maret Surakarta, Farmasi Akademi of Putra Indonesia Malang, Politeknik Negeri Malang, Politeknik Negeri Semarang, Universitas Negeri Semarang, Universitas Gajah Mada, Telkom University, Universitas Muhammadiyah Yogyakarta, Universitas Widya Husada, Institut Teknologi Telkom Purwokerto, Politeknik Harapan Bersama, Universitas Brawijaya, Politeknik Negeri Indramayu, Universitas Mutiwaluyo Semarang, Universitas Negeri Surabaya, IAIN Pekalongan, IAIN Salatiga, Politeknik Perkapalan Negeri Surabaya, Universitas Jenderal Ahmad Yani Yogyakarta, Universitas Muhammadiyah Surakarta, Universitas Islam Negeri Wali Songo Semarang, Universitas Tidar, Universitas Pertamina. From Sumatra, there are Universitas Bangka Belitung, Universitas Maritim Raja Ali Haji, Universitas Muhammadiyah Bengkulu, Universitas Prima Indonesia, Universitas Lampung, and Politeknik Negeri Sriwijaya. From Kalimantan, we have Institut Teknologi Kalimantan. From Sulawesi, Poltekkes Kemenkes Makassar, Universitas Haluoleo Kendari. From Maluku, Universitas Patimura. And from Papua, Universitas Musamus Merauke. A large number of papers submitted to ICENIS indicate that the interest in the field of energy, environment, epidemiology, and information system gains a continuous rise in Indonesia and worldwide. National Institute of Research and Development, Ministry of Health of Republic Indonesia, Research Center for Biomaterial, Indonesian Institute of Science, Agency of the Assessment and Applications of Technology, or BPPT, Human Resource Development Agency for Minister and Energy and Mineral Resources, Central of Industrial Pollution Prevention Technology, Ministry of Industry, Indonesian Agriculture Environment Research Institute. They all that I try to appreciate all their participate. Hope I didn't miss one. We are also proud and thanks to plenary speakers who are qualified to share that valuable information and knowledge at this conference. Prof. Peter Gell from Federation University Australia, Prof. Magali Kok from Boston University USA, Prof. Wiku Adhisa Smita from Indonesian Government Spokesman for Handling COVID-19, Prof. Arif Satria from Ibb University Indonesia, Prof. Elko van Berg from Amsterdam University, Prof. Robert Pikuk from University of the Free State South Africa, Prof. Fatima Yusuf from University Putra Malaysia, Insinyur Laksmi Dewanti from the Indonesian Ministry of Environment and Forestry, Dr. Putih Warsito from School of Postgraduate Studies Undip, and Dr. Sitaraman Vaidya Nathan from the University of Sheffield, UK. On behalf of the ICENIS 2021 committee, we wish you all participants to have good attainment. I would also like to take this opportunity to thank the organizing teams from the School of Postgraduate Studies Undip for all their hard work and dedication in preparing for this conference. We have tried our best in conducting this event, but we humbly realize that we may still be lacking in some parts. Accordingly, we would like to apologize for any inconvenience. In this pandemic COVID-19, among of us lost families, friends, colleagues, time goes, and we have to adapt to this situation. All of you in this ICENIS are proof for the adaptation work. In the end, I truly sorry to hear that loss of two participants, Juliana Cristanto from Public Administration Department, Faculty of Social and Political Science Undip, and Indratin from Indonesia Agriculture Environment Research Institute, Indonesia Ministry of Agriculture. Our condolences and prayers help comfort their families and friends in ICENIS and hasten the journey of their soul to heaven. I sincerely hope you will enjoy today and the next day of the conference and networking. With great pride, we present ICENIS 2021 and we wish you an inspiring time. Thank you for your participation. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor, for the opening remarks. And then the next opening speech would be from Deputy Dean for Academic and Student Affairs of Postgraduate School, representing the Dean of Postgraduate School, Universitas Diponegoro. We are pleased to have you, Professor Hadianto.
Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. I would like to convey the greeting from our deans who's not able to join us today due to still under recovery from his sickness. And I would like to give this welcoming speech on of our deans. The Honorable Rectors of Universitas Diponegoro, and in this occasion represented by Vice Rector for Research and Innovations, all Vice Rectors, all Deans, and all keynote speakers, distinguished guests, moderators, and also all participants. Welcome to School of Postgraduate Studies, Universitas Diponegoro, and it is my pleasure to welcome you all to the International Conference on Energy, Environment, Epidemiology, and Information Systems, which is organized annually by the School of Postgraduate Studies. The name of the conference is actually reflected from our study programs. And this year, 6th international conference is conducted since the first conference in 2006. So the second after, which is started in 2020. Although, but I believe that this conference still becomes a very good medium and opportunity for us to communicate and share the newest information about the knowledge, concept, theories, and result of the research in multidisciplinary scope of energy, environment, epidemiology, and information system. Through this platform also, we do hope that the conference will continue to serve and encourage all the participants, not only to present and share their scientific research findings, but also build a global network while learning the latest advancement and development of research in multidisciplinary field, despite we are in these uncertain situations due to pandemic COVID-19. The topic of ICENIS this year is the impact of COVID-19 pandemic on water, environment, energy, information system, and strategy for their adaptation and mitigation. And I think this very much fit to the current situations. I hope by setting this topic, we will have contribution from different aspects in reducing the impact of pandemics to the society. We also are happy to inform that since the first conference in 2016, all presented articles have been published in Scopus Index Proceeding from our partner publishers. And this year, the conference received enormous number of submissions from the participants. More than 400 abstracts from various affiliations and countries have been received by the committee, showing that the ICENIS is the tremendous and very popular conference in Indonesia. On this occasion, I would like to congratulate also the organizing committee for their tremendous effort in organizing the conference that make this event happen. Also the director and all the plenary speakers who will be sharing their thought and perspective in these greatly events. Last but not least, to the presenters, I wish you all the best and have the great scientific competitions in these events. Lastly, I hope all participants will find this virtual event to be fruitful with wonderful moments of knowledge and experience sharing. Thank you and wish you happy conference. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Prof. Hadianto, for the remarks. Next up, we would like to invite the Vice Rector of Research and Innovation, Universitas Diponegoro, Prof. Ambarianto, to deliver a welcoming speech and to officially open our 6th ICENIS 2021. Please give it up for Prof. Ambarianto.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. Honorable keynote speakers, Professor Elko van Broek from Amsterdam University, Professor Peter Gel from Federation University Australia, Professor Magali Koch from Boston University, USA, Professor Fatimah Yusuf from University Putra Malaysia, Professor Robert Peacock from University of the Free State, South Africa, Dr. Sitaraman Vaidyanathan from the University of Sheffield, UK, Professor Wiku Adisasmita from Indonesian Government Spokesperson for Handling COVID-19, Professor Dr. Arif Satria from Ibb University Bogor, Indonesia, Engineer Laksmi Dewanti, MA from Indonesian Ministry of Environment and Forestry, Dr. Budi Warsito from School of Postgraduate Studies, Diponegoro University, the Dean of School of Postgraduate Studies, and all deans, all conference guests, and all participants. It is my great honor to welcome you to the 6th International Conference on Energy, Environment, Epidemiology, and Information System 2021. This is the 6th International Conference organized by the School of Postgraduate Studies, Diponegoro University, following the success of previous international conference, which were conducted since 2016 until 2020 last year. With its remarkable achievement, this event is expected to be continued annually. We are very much support this prestigious conference, which is attended by more than 400 participants. Diponegoro University, or in short, you can call us Undip, Universitas Diponegoro, is a prominent university located in Semarang City, the capital of Central Java, so in the middle of Java Island. Undip, or Universitas Diponegoro, has strong tradition to carry out education and research, as well as community services. The university has 11 faculties and 2 schools, including School of Postgraduate Studies. We are also organizing undergraduate, master, and doctoral programs, as well as specialist and profession. Ladies and gentlemen, the topic of this conference this year is the impact of COVID-19 pandemic on water, environment, energy, information system, and strategies for their adaptation and mitigation. The topic is very important since human security has been considered as the basic need for community, even in a much larger scale, a country like Indonesia, for example. The government or the country must ensure that these needs are covered and secure for its citizens or its people, which can be done through many Sustainable Development Goals, which is initiated by United Nations. Currently, we are facing global challenges, not only in the depletion of natural and energy resources, environmental degradation, for example, but also pandemic COVID-19, which is currently major health problems, which needs to be tackled by every one of us, by every country in the world. I hope this conference will be an excellent platform to strengthen our concern and effort in confirming sustainable development for future human security. Through this conference, I hope all experts and researchers could meet and share their experiences and knowledge to have explicit understanding regarding the complexity of the problems. I also hope that this conference will present a memorable learning experience to all contributors and participants. It is expected that papers presented in this conference are documented for all future references and encourage further research in relevant areas. Lastly, with the permission of Allah Subhanahu wa Ta'ala and all of you, the 6th International Conference on Energy, Environment, Epidemiology, and Information System is officially open. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Professor Ambar, for opening this special occasion, the 6th ICENIS 2021. So it is officially opened. And we would like also to say welcome and also good morning to Professor Magaliko, who has joined with us. And maybe in Boston today, I would like to say good evening because it's still almost 10 p.m., right, Professor? So welcome, Prof. Magaliko.
Thank you very much indeed. It's already almost 10 p.m.
Yeah, okay. So today, as it is officially open, we are going to have the plenary session. That would be 10 plenary session, and it's divided by 2. And this day we are going to have 5 plenary sessions. It will be led by our moderator, Professor Sudarto Hadi. He was an alumnus of Faculty of Social and Political Science, Universitas Diponegoro. Then he took the master's degree in Environmental Studies at University of York, Canada. Also, he took a PhD at University of British Columbia, Canada. He has been a lecturer at Universitas Diponegoro since 1980. And in 2000 until 2002, he was Deputy Ministry of Environment, Republic of Indonesia. In 2010 until 2015, he was rector of Universitas Diponegoro. He also focuses on environmental management in public and private sector. Without further ado, we are pleased to welcome you, Professor Sudarto Hadi.
Thank you, Cheha and Gendis. Did you hear my voice?
Yes, Professor.
Okay.
Yes,
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Excellent speaker, distinguished guests and participants. It is a great honor to be a moderator at the first plenary session of 6th ICENIS, International Conference on Energy, Environment, Epidemiology, and Information System. At the plenary session, as you can see at the agenda or rundown, will run from 9:05 until noon, until 12. So we are on time. I think we are all organized with 5 outstanding speakers. And each speaker has 30 minutes at the most to present his view. And the rest 25 minutes will be utilized for discussion. At the meantime, all participants can raise a question, comments through meeting chat or room chat, and kindly mention to whom specifically your question to be addressed. The timekeeper will remind the speaker 5 minutes before the time finish through the screen. So I hope it will not disrupt the speaker. So kindly take attention while presenting. Okay, let us start with by inviting Professor Peter Jell to present his view. And before this, to the operator, kindly show the short CV of Professor Jell. Yes, Professor Jell affiliates with Federation University in Australia. He finished from Monash, all from Monash, from bachelor to PhD. And you can see his working experience from Monash, Paris, UK, Adelaide, and the last one is Federation University. And his research focus on paleoecology, Rapsar wetlands, and climate change. Okay, I would like cordially invite Professor Peter Jell to share his view. 30 minutes for you. Time is yours, Professor Jell.
Many thanks, Professor Sudarto.
Nice to see you again, Professor Jell.
And yes, I'm endeavoring to share my screen.
Yes, please.
I'll have to put that on the slide. It's all working. Okay,
Yes.
I'd like to open by expressing my great empathy for the challenges that you are confronting in Indonesia we in Australia are confronting the same challenges, of course, but thankfully not to the scale that you are having to deal with it through this and last year. I think on account of that, ICENIS 2021 is a great testimony to the resilience of all of my colleagues there in Semarang in the face of the pandemic. And so I congratulate you all on a 2-day conference in the middle of these very challenging days. And also to that end, I thank you, the organising committee, greatly for this privilege of providing the opening keynote address today to the 6th ICENIS. You may see I'm endeavouring to get into the tropical spirit. I have my batik shirt from Semarang, and I have a glass of tropical juice with me because here in Ballarat it is going to be merely 6 degrees Celsius today. So it is very cold, and I trust it's much warmer there in Java. So the organisers have asked me to cover something across the environment and pandemic space, and you'll come to realise that I'm not an epidemiologist, but of course, to some extent, we are all pandemic experts to some degree, and certainly in Australia, there is no shortage of commentary around the pandemic. So I'll be covering a little bit of my observations around COVID-19, the background, impact and response, and then I'll focus more on areas that I'm more familiar with in the climate change sphere, and then see if there's any lessons to be learnt either way in terms of adaptation planning for future climates. So as we well know, the coronavirus, COVID-19, is a zoonotic virus. It's emerged from species crossover, and we can see that in fact most of the world's emerging diseases are of that nature. So it's perhaps we should not have been surprised by the emergence of such a virus. Perhaps we've been surprised by its extent and the rapidity of the infection. But there have been many pandemics. A century ago, the so-called Spanish flu, which I don't think we should attribute to the Spanish, polio and other diseases for which we have created vaccines, and more recently, recent decades, SARS and Ebola and others. And these, the epidemiologists have told us, warned us of the increasing prospect of a global pandemic. I'll just draw on one of the major issues that we faced in Melbourne last year. And of course, we've been fortunate not to have faced the magnitude of change that have been experienced elsewhere. But we had quite a COVID threat in the middle of last year in Melbourne. And we can look at the precursor conditions to that. Over the last few decades, we have decommissioned our quarantine facilities, they being seen to be no longer useful in a non-pandemic world. So we lost the infrastructure that we might have had to rapidly respond to the evolving virus. In our neoliberal economy, we have privatized aged care facilities, which are a service to our community. And that's a consequence of our focus on profit rather than community care. And that's left us vulnerable to dealing with the pandemic. Also, as part of that, to maximize profits, we've shifted from a permanent workforce to a casual workforce. And so many workers have been required to work across multiple workplaces. 3 hours here at one aged care facility, 2 hours at another aged care facility. And then that lack of financial reserves has reduced their capacity to quarantine when they felt ill. This lack of investment in permanent care staff led to a great vulnerability in the Australian aged care workforce. And in Melbourne, it meant that staff were not able to quarantine and had to move from one workplace to another, spreading the virus. And this, if you know much about resilience cycles, is a classic example of the alpha phase. This is where growth is maintained, or productivity is maintained, not by the availability of resources increasing, but by shedding redundant elements, optimizing the path to increased productivity. And it's these redundant elements that are very much the adaptive capacity when society experiences a shock. So the lack of permanent staff might have saved money, but it exposed our aged care sector to the virus, both spreading it and the incapacity to have staff who are infected go into quarantine. And this has led to 800 deaths in the aged care sector in Melbourne at the height of our pandemic experience last year. The global response, and I sort of draw on countries such as perhaps the US, and I think they're willing to admit issues that they faced last year with respect to the pandemic, of delay, denial, and preferencing the economy over the welfare of humans. And we see that in Australia, and I see we have some experience from that in the UK, perhaps. I'm not sure of the experience in Indonesia. But on account of these responses, we have been playing catch up. Enormous numbers of infections in Europe and the US, and we're now seeing the challenge of the Delta strains and other evolving strains. Some places are vaccinated rapidly. In Australia, here in Ballarat, we are 23% vaccinated, which is very slow for a wealthy Western nation. And we've had a lot of confusion over the risk. The education process of the challenge of AstraZeneca has led to a lack of uptake. And of course, one of our experiences is that the rich nations are the ones that are able to develop the vaccine. And so it relies on interaction with the developing world to ensure that the rest of the planet is vaccinated to this disease as well. So the developing world is exposed to that generosity, I could call it. However, despite these challenges, there has been a massive investment in resources. There's been stimulus measures, there's been huge investment in medical protection of the community, as well as the mobilization of resources for vaccination research and production over a very rapid time. And we can congratulate those that work in those areas to producing effective vaccines in a much shorter time than would typically be the case. We're also seeing widespread compliance. I'm surprised how compliant my communities are in Australia. We're often being seen as rather renegade, where in fact, when it comes to COVID, we're extremely compliant to the direction of government. And we're seeing broadly at all levels of community, science, government, a very rapid response. Why have we seen a rapid response? There is a clear cause and effect. Of course, in Wuhan, they saw that very quickly and responded incredibly rapidly. And China now has very low, or had very low infections in recent times. We can witness very readily the direct impact on large human populations and how it's caused super spreading events, etc. But I think critically also the time frame of a pandemic matches the political cycles, so that there is political value in prompt response and positive outcomes in terms of these short political cycles. So it's in the interest, for example, of our federal government in Australia to have a successful vaccine rollout before the next election next year, because that might impact upon their political stocks. There is also a demonstrable economic impact, and it's clear that we need to control the virus to allow communities to return to activities that drive the economy of societies. Now I'll move on to climate change, and I think there are some contrasts we can draw on here. Of course, similar sort of time in terms of warning, because Arrhenius in 1896 saw the link between carbon dioxide concentration in the atmosphere, trapping long-wave radiation, and global warming. So the planet's had some warning. And the process is that the carbon cycle has been modified because of the emissions of long-buried carbon reserves as fuels, and we are all well aware of that. And we know it's those carbon reserves that are important because, for example, the radiocarbon process has been impacted by the emissions of fossil fuels in terms of the relative proportions of isotopes important in dating fossilized material. But we also know deforestation has had a role because reducing the amount of organic matter on the surface of the planet has reduced our capacity to fix carbon dioxide in the atmosphere. Now, when I was a student, in my first year, which I'll let you know was in 1978, my first essay was on global warming, as it was uncontroversially called back then. And my principal resource was the proceedings of a conference in Massachusetts Institute of Technology from 1969. And I think it's worth revisiting some observations from that book, that they observed that an 18% increase in carbon dioxide would lead to an increase in temperature on the Earth of 0.5 degrees Celsius. A doubling might mean 2 degrees Celsius. So of course we know the further we go back, the more conservative the forecasts were. However, that's not far off the mark. And the probability of direct climate change in the 20th century might be low, but in terms of long-term potential consequences, the societal reactions to such threats are so serious that we must focus on learning about climate change. Only through these measures can society hope to have the time to adjust to the changes to make the ultimate changes necessary. So we could see from that observation that the scale and the urgency of the climate crisis was well recognized over 50 years ago. And increasingly through to the present, with the IPCC reports, etc., we're seeing modelling and paleoclimate work providing the context for the change we can expect. Concentrations of CO2 are now 415 parts per million, but the ice cores never vary between 180 and 280 parts per million over 800,000 years. So we're in unusual territory in terms of carbon dioxide concentration, and that's increasing by more than 2 parts per million per year. We can see from coral records that global temperatures are anomalous over the last 1400 years. And the modelling tells us if we get to 450 parts per million, then we may yet experience 3 to 4 degrees increase in global temperatures, more at the poles than in the tropics. And a simple bit of mathematics will tell you if we're at 415 today, increasing by 2 per year, 450 is not far off. And global scale analysis of the impact on people on the planets show that we are exceeding our safe operating space for nitrogen, biodiversity, and for climate already. And many are calling for us to return to less than 400, 350 parts per million. However, given these warnings over long periods of time, the response to date has been quite modest. We've had major global political meetings, Kyoto, Copenhagen, Paris, and Glasgow, but political interests have moderated an appropriate response. And the cartoon you can see there is myself and Bishop Huff, who during the Copenhagen summit sought to influence some of the people of Western Victoria in terms of the challenge of climate change. some of the responses have been very negative. Lobbying by fossil fuel interests. And Mike Mann, the original author of The Hockey Stick, has been followed around the planet as he gives keynote addresses for people to try and deny and delay his research. So the modelling research has been challenged, and to a degree also that's been effective because the science of planetary climate change is extremely complex and difficult for society to understand, perhaps in contrast to COVID. Also, there is very long lead times between rising carbon dioxide concentrations and the temperature effect and other effects. So there's a clear mismatch between political cycles. Why would my government move rapidly in the next 6 months to mitigate carbon? Because the effect will be felt many elections down the track, or mostly. So one of the challenges is that is described as a wicked, complex, global scale challenge and very difficult for governments to deal with. What are some of the risks of delay? As carbon dioxide concentrations continue to rise, the response is more likely to be abrupt rather than linear, and this is difficult for many governments to perceive. It's known that the oceans have a limited capacity to absorb more heat, and they are rapidly topping up, and at some point that heat will enter the atmosphere and not be absorbed by the oceans. Also, there are critical feedbacks in play, such as the loss of ice at the poles, which will change the albedo effect and lead to more temperature or heat absorption, as well as the threat of the release of methanes and even more active greenhouse gas from permafrost as it melts, and marine clathrates. And this is anticipated to lead to the risk of a runaway greenhouse effect. So even if there was political will when these were in place, the challenge of actually reversing rising temperatures would be far greater. And it's been now well known that even if we decarbonise rapidly, our capacity to reabsorb carbon in our environmental systems now is becoming increasingly limited. And this forecast from 2010 said that if we don't mitigate by 2020, that is maximum carbon emissions, we'll have to follow the red pathway or a 9% pathway per annum of decarbonisation to achieve a stable, habitable climate. And Stadger has observed from research from the UK that in fact, if we get to 450 parts per million, it may take many centuries to extract that carbon dioxide from the atmosphere. So the momentum behind warming means that many generations will regret any delay that we play on now. However, optimistically, the slow cause and effect does buy us some time. The response requires mitigation, and we're hearing this in the news about the upcoming meeting in November in terms of getting carbon dioxide concentrations below 400 and preferably to 350 parts per million. But given the embedded consequences of past emissions, we also need to implement measures of adaptation. And I happen to be the chair of a local climate change adaptation group, which is endeavouring to implement these sorts of measures in my region. If we just look at fire risk, over the long term, the evidence of past fire, and that's the paleo fire record from Eastern Australia there on the right, shows that fire risk is greatest when forests dry out. And the forests originally grew in wetter climates. Fire requires people, the usual source of ignition or lightning, storms, surface heating, and high temperatures. So all the Mediterranean zones of the world have forests or at least dense vegetation, which was formed under moisture through the last 5,000 or 6,000 years. And they are all now drying and warming. In Australia, we can observe from the long-term record that by 2050, we'll be in an unprecedented combination of forest, people, drought, and heat. And our present response to this fire risk is to implement indigenous burning practices that were effective in much cooler and wetter climates. And while this is really important culturally, it's an example of maladaptation or adaptation to a past climate, not a future one. I'm a paleoecologist, so I have to show a pollen record, but this is a record of vegetation 100 kilometres to the west of me here over the last 200,000 years. And it shows the period of when people arrived in Australia. And you can see under grass and daisy, for the first 55,000 years of existence, they were living in a plain, not a forest. And the forests, eucalyptus in green, are really only 6,000 years old. So their fire burning practices are very recent relative to the 65,000 years of their history. So we need to explore adaptation measures that are ready for the future climate, not the climates of the past. Importantly, where you are, sea level rise is and will be an increasing issue. The embedded warming that I mentioned means that irrespective of scenarios, we'll have sea level rise. Ramsdorff has suggested 80 to 150 centimetres by the turn of the century. However, the last time we got to 450 parts per million, the sea level was 3 to 6 metres higher. So that will be the ultimate result if we continue on our present path. Adaptation to this will involve a staged retreat from many coastlines at considerable cost, but it requires planning now because we're already 20 years into this century. And we can see evidence of a 500-year church being impacted by modern storm surges. 500 years ago, you wouldn't have built, you would have built that church there unless you knew that you were going to face these sorts of sea levels. There are already publications advising on how we might structure this staged managed retreat. It requires anticipating the removal or abandonment of hard structures, to cease maintaining such structures and directing investment elsewhere, restrictions on coastal land use, advising communities to where to retreat, the removal or relocation of infrastructure, including transport links. And these actions may require transition over many years, and for planning to signal that this change is approaching. Where I am, we still have planners agreeing to build within 80 centimetres of present sea level. So we need to trigger decisions that send us on new pathways that enable us to resist the hazards that we will inevitably face. And I know coastal inundation at Semarang is a hallmark of what will happen into the future. Also, our natural ecosystems, for which we have a duty of care, will be impacted by climate. But they're already fragmented, degraded, and our biodiversity is depleted on account of direct human impacts. I remind you that the Living Planet Index of the Worldwide Fund for Nature identifies freshwater ecosystems in particular have suffered greatly in terms of biodiversity loss since 1970. So we need to focus on them as much as our terrestrial and marine systems. So we need to reduce the human footprint to enable these systems to potentially adapt to a rapidly changing climate. Dealing with human impact and climate at the same time may be too much of a challenge for many of these systems into the future. So, my last slide, can we learn from this rapid response to COVID in terms of our needs to respond to the climate change? We can observe some parallels. Climate change will also impact mostly on poor communities and the developing world. But we can see within preparation for COVID, there is some international cooperation looking at harnessing funds to vaccinate populations in developing countries. This is partly because of our global travel, our ability to move around the planet and to reduce cross-infection, I suspect, but I would hope that it also is about managing the risk and the grief that will come in developing countries. Clearly, the risk of COVID drove rapid response. Climate change increasingly is being recognised as a likely cause for accelerating deaths, not just through heat, although those in North America recently are beginning to recognise that more acutely, but also all the other ancillary impacts of a warming and in some places drying climate. And the recognition of that risk may prompt action, perhaps not as rapidly as COVID, but more rapidly than we've experienced in the last 10 or 20 years. In terms of the economy, those dealing with COVID recognise the importance of managing COVID for a healthy community and the importance of a healthy workforce and a healthy environment on economic prospects. And I think increasingly the world's businesses and industries are beginning to recognise that in terms of climate change. And many large businesses, multinational companies, are abiding carbon neutral policies. COVID reveals that society can rapidly respond to a crisis. And while 2021 is particularly challenging, we look forward to emerging from this challenge much more wise than when we entered it. And so that means that education is the key to mobilising that response. And I congratulate the organisers of ICENIS, who are, despite the challenges you're facing, are persisting with this pursuit of educating the community and educating the young members of our society to be the teachers of the future, so that we can more rapidly respond to the dual challenges of pandemics now and in the future, the climates of the present and the climates of the future. So congratulations on the ICENIS series. I enjoy my participation each year, and thank you for your attention. And I'll hand over to Professor Sudarto. Thank you very much.
Thank you, Professor Jel. So if we are at offline seminar, we will applause this presentation. Okay, Professor Jel shared with us at the part of his presentation is about COVID-19 globally and specifically in Australia. And then at the second part is about climate change. So there are keywords that we think about pandemic and climate change. One, natural ecosystem are widely fragmented, degraded, and depleted by climate change. So we need to implement measures to reduce our human footprint to allow our natural system to adapt to a rapidly changing illuminate. And with regard to pandemic COVID-19, the key word is education is the key to mobility rapid change. So if you have any question or comment, kindly write down through meeting chat. Professor Jel will respond it. Okay, the second speaker is Professor Magali Koch from Boston University. She will present her view through video, but before that, she will make introduction. So this is her CV. Her education is from Cologne, Germany, and Boston. And you can take a look working experience. She is affiliated with Boston, Harvard, and Tufts University. And her research focuses on remote sensing of environmental change, exploration of groundwater in arid lands, assessment of natural hazard. And the topic of her presentation is observing water resources from space, from flood monitoring to groundwater assessment. Professor Magali Kok, time is yours.
Thank you very much, Professor Hadi. And I just want to mention that although I recorded my talk this morning in my office where I have better equipment, better camera, better mic, everything, I'm right now at home. I will be monitoring the chat, so please feel free to enter any questions you may have, and also if there's any technical issues on your side in Semarang, I'm here to jump in anytime. Thank you.
Thank you, Professor Kok.
Good morning. My name is Magali Koch. I'm research professor at Boston University, the Center for Remote Sensing, and it's a pleasure to be part of this conference. I would like to thank the conference chair and the scientific committee for giving me the opportunity to talk about remote sensing technology and its use in water resources. Specifically, I will talk about its use in flood monitoring and also groundwater assessment. I want to start by addressing a very important issue, which is the global water and food security issue. We often talk about water and food crisis, and related to that is, of course, the use of water for agriculture and also urban flooding. So these are two aspects where remote sensing technology can certainly be used to assess the situation, to monitor these uses. And I want to briefly explain what can be done with remote sensing. And I want to illustrate the use of remote sensing in one case study, which is related to my own research in Egypt, where we were investigating groundwater resources in a desert area that is being converted into agriculture. Well, let me start with this beautiful view of our planet. It's often also nicknamed the water planet because it's full of water, as you can see here. From this perspective, there are no major land masses or continents visible here. We're looking at the Pacific Ocean, and together with these huge, oceans, which make up 2/3 of the surface of the Earth. In addition to that, we add also the atmosphere, which is full of water in the form of clouds and water vapor. How come that we talk about the water crisis if we have so much water? So let's take a look at some statistics. We know that 1 billion people around the world don't have access to safe and clean water. Many more have access only through communal water supply system. Over 2 billion people are living in water-stressed countries. So that's an enormous, population who basically don't have access to appropriate sanitation, clean water. It's a big problem. In the next 50 years, there will be severe impact on quality and quantity of water due to climate change, but also mismanagement of land and water resources. So we know that. And linked to that is, the issue of water and food security. So we know that the increasing population is going to increase also the demand for water. And in the face of climate change, this is a huge, huge problem. We know that, water is a necessity. We cannot live without water, and it has no substitutes. So we have to address this problem. And at the same time, we also know that water resources in semi-arid and arid regions are likely to suffer disproportionately from climate change. So those are the regions we should really pay attention to, because first, they're the first one that are going to show these changes. This map is to show you which countries are considered the water-rich countries or water-poor countries. So the very dark blue obviously shows the countries that don't have an issue with the lack of water, but the light-colored regions or countries, those are the ones who are mostly concerned. Of the 15 most water-poor countries in the world, 10 of them are in the Middle East, right? And so if we compare this map with the next one, which shows us the water used for irrigation, right, or agricultural irrigation, we see that, well, the distribution is very uneven. So the size of the pie indicates the volume of water needed for irrigation, but the colors within each pie indicates the source of the water. And there are basically three main types of water sources that can be tapped for irrigation. The green one relies on local precipitation and soil moisture. So that's the renewable water. And that's the good type, right? Because it's being renewed as we use it. And the blue one, the light blue, is that represents river water. Again, renewable, but not in situ. It's oftentimes renewed in the uplands, right? And then the very dark blue is the one we are mostly concerned with. And that's the non-renewable water that is oftentimes used for irrigation. That's groundwater that is not being replenished, not being recharged. And it's fossil water. And as you can see from this map, that type of water source is being used in arid, semi-arid regions of the world. On the other hand, urban flooding is another major challenge we're facing. So projections indicate that by 2050, 2/3 of the world's population will be living in urban areas. And these urban areas are mostly developing and expanding in coastal regions. So natural and human development factors are influencing our cities. And coping with flooding in expanding urban areas and increasing population is a major challenge for governments, decision makers on all levels, from local to national. So in order for them to make a decision, they need to rely on accurate and updated information. So we also know that rapid unplanned increases in urbanization, growing numbers of slum dwellers and inadequate infrastructure make our cities more vulnerable to urban flood. However, this is a problem not only faced by developing countries, also in developed, industrialized, rich countries. Urban flooding is also an issue. And our cities are therefore at the front line of climate change. So climate is changing and affecting basically everyone. Now, let me talk a little bit about remote sensing and its use. It has many applications, and here we're have like three major types of applications. On one hand, we use or we can use remote sensing to monitor the air quality, pollution, and so on, and that's relevant for our health, right? But also for cities and so on. On the other hand, we use remote sensing technology for water resources, whether it's flood or drought monitoring or severe weather events. No? And then the third category would be land use, land change, and ecology. No? So these are major applications of remote sensing data. Now, the data is collected by a number of satellite missions, and the measurements they take are not immediately usable by the end user. We rely on these satellite systems because they are constantly and continuously orbiting around the Earth and taking measurements in a repetitive manner and building these enormous archive of images, right? And the data needs to be processed. It needs to be converted into something that the end user can use, right? Fortunately, we live now in an era where we have high-speed computing capabilities and so on, and algorithms that can actually process enormous amount of data. So, because the data generated by these missions, I mean, these are like thousands of images, collected by multiple sensors, it's almost impossible to manually analyze such amount of data. No? But with machine learning algorithms, artificial intelligence, we have the tools to convert space data into information that the end user can then use in their environmental applications. Here's just a list of parameters that can be obtained from these satellites in terms of water and water resources studies, whether it's precipitation, surface water, soil moisture, groundwater, evapotranspiration, infiltration, runoff. I mean, there's a number of parameters that can be directly or indirectly extracted from these satellite measurements. So in green, you see those that can be derived by combining basically surface-based and remote sensing observation. In blue, you see those parameters that need to be calculated based on other observable geophysical parameters, so they're not readily retrieved from the satellite measurement. And then in red, runoff requires actually the use of models or a water balance equation in order to derive that parameter. No? The missions that are mostly used for generating these parameters, or the most popular missions, say, are listed here. The top is Landsat because it's the oldest mission, has been around for more than 40 years, collecting continuously images over the entire world. I'm also listing a number of other missions, and also from the European Space Agency, Sentinel-1, which is the radar mission. This list is not complete, but it just gives you an idea of which missions are currently available and collecting data that can be used for water resources studies. No? In this table, we see the same number of missions, except that this table also adds some properties. So the spectral region they operate, and this is to show you that some of these satellites, they operate in the optical near-infrared or infrared region of the spectrum, whereas other missions, they operate in the microwave region of the spectrum, no? And some characteristics, no? And or what type of parameters they collect, or what parameters can be derived from their observation. So let me give you an example of the use of remote sensing from my own research in Egypt. Now, Egypt obviously is, lies in a very arid environment. Here we see the Nile Delta and the Nile Valley, right? So agriculture is the most important consumer of fresh water in Egypt. No? It's amazing for many people to find out that 95% of the water, the natural water resources in Egypt, is consumed by agriculture. So it's basically all the water is being used for fresh water. I'm talking about fresh water being used for growing food. So with the increase of Egypt's population, sustainable development of agriculture areas has become a very important aspect that the government, is concerned of. And so they want to make sure that there's enough food for everybody, and that means that they need to actually increase the area that is being used for agriculture. So traditionally, Egypt has relied on water from the River Nile as the main source for irrigation. However, the problem is that Egypt's allocated Nile water share is fixed. There's only a certain amount of, cubic meters per year they can redirect or basically tap and use for agriculture, right? So they're looking for a way of expanding the agriculture activity, but the main water source, the Nile River, has only a certain amount of water that can be used for agriculture, no? And that's why they're looking into ways of reclaiming desert areas close to the Nile and maybe use groundwater as the water supplier. The problem with the groundwater in this arid environment is that it's usually not replenished. It's not a renewable source, no? Except that close to the Nile and also close to the Aswan, the Lake Nasser, there's potentially some recharge happening through leakage. So the Nile riverbed is leaking water as well as the Lake Nasser, no? And that's why we explored this area to see if there's currently some water recharge happening via fractures. No? This is just to show you where the Egyptian government is sort of expanding its agriculture activities. Some pictures, and often in most of these cases, the water is being the agriculture area is being irrigated by bringing water from the Nile, no, through a canal system. So our area lies in the south, near Aswan. Aswan is somewhere here, and traditionally this area has been used for agriculture for decades and centuries actually. And you can see here in the eastern part that agriculture fields are expanding towards the eastern desert, no? Tapping also some water from these wadi systems. But most of the water is being brought from the River Nile to these agriculture areas. And that's possible because the terrain here is more or less level with respect to the Nile. So they're more or less at the same elevation. The problem with the western desert on the left side of the Nile is that this flat area is higher up. It's like 100 meters above the Nile. So there's no way to bring water from the Nile up to that plain, except if you pump the water, but that's not something they are considering. So we want to look at this Western Desert, the plain, El Galaba plain, more closely, because the geological map, the official geological map, shows this area more or less featureless. I mean, there are only two surface sediment types indicated by this map. Sand sheets, so medium to coarse sand, and then sand, mixed with gravel, and that's it. So there's not a lot of geological information available. So we took a look first at optical images, and we see that this plain is bounded by the Nile River and also by an escarpment, basically a calcareous, ridge or plateau. When we look at this same area, but using radar, we get a completely different picture of the landscape. So here we see the plain again, and all of a sudden, it's no longer featureless. It shows many, many, linear features, and radar has the capability of penetrating loose sand and actually showing what's under the sand, aeolian sand. And what we discover is that we finally see the ancient fluvial landscape. So basically, the landscape that existed in previous geological times when the climate was different. It was more humid. And also in this plain area, many rivers and streams were crossing it. You can still see the paleochannels. This is a paleochannel, which is no longer visible on optical, but becomes visible with radar. And the same here, there's an important channel here that sort of connects with another channel on the other side of the Nile, but it is being, dissected by the Nile River, which is a younger river. And so this is an old river system that no longer exists, but it used to be there. And we geologists want to know where these paleochannels are, and also because they're usually provide favorable conditions for groundwater to accumulate. This is an ancient delta system. At the same time, we also want to improve the surface sediment map, and we can do that with radar. Again, we can differentiate between different types of sands and gravels depending on their, their size, whether it's fine sand or gravelly sand, and so on. And that's all based on radar, because radar is very sensitive to surface irregularities, and that gives us geologists a tool to actually detect how coarse, how big the sand particles are. In remote sensing, we always need to do some field check because we need to be able to interpret what we see on these images, right? And so what we did with this surface sediment map that we obtained, extracted from a radar image, the different colors represent different types of gravels or sand and gravel or sands. We went to the field and checked the properties of these classes. Not only that, we also were able to measure the paleocurrents, basically the direction with which the streams were flowing in the past and depositing these sediments. So that's called paleocurrent measurement. And then relate that to the surface sediment map. So this polarimetric radar shows the depositional direction of the surface sediments. It came from different directions. not all at once. So, there's a sequence with which these sediments were deposited, but they provide a lot of information in terms of groundwater movement and accumulation, and where it may potentially, currently be stored. In addition, we need to know also the fractures that may serve as water conduits. And the geological map doesn't really show many fractures here in this plain area, but with radar we were able to actually map many more fault systems and fractures. And based on this map, we derived what we call a fault density map, which gives us sort of an indication of where are potentially, good conditions for groundwater to move, and also to see whether there is a connection between these fractures and the present time river, which is the Nile River, and also Lake Nasser. Remember I mentioned that we were interested in knowing whether the groundwater that exists in this basin from previous, geological times, whether it's currently being, recharged, at least partially, by the River Nile and also by the Lake Nasser. So this is just an example to show you the application of space technology to map something that is not visible on the surface. Groundwater is not visible on the surface. It's, by definition, it's located in the subsurface, right? So ancient fluvial surfaces are often, concealed by these aeolian deposits, the sand sheets. And so that inhibits the discovery and mapping of potential groundwater recharge areas. But with radar, we're able to map them. Radar can penetrate dry desert sand and provide valuable information about near surface features, which is complementary to optical sensors. So we're able to detect and map the fluvial landscape under the Aeolian sand. And possible groundwater recharge from the Nile River needs to be confirmed by comparing the hydrochemistry of water samples from drilled wells with those from the River Nile. So that's another aspect that needs to be done before we can actually say or discard whether present day recharge is occurring or not. And once we know that, then we may be able to drill for water and extract it for irrigation, and sort of ensure that we have a sustainable way of irrigating the desert area. I want to finish my talk by giving you just a quick overview of some of the activities that many space agencies are doing. Not only NASA, many space agencies in many countries are making an effort to make their huge amount of data that their satellites are collecting available to not only the scientific community, but also the public, the general public. And so these data portals, they serve many purposes. They can be used for many applications, whether it's monitoring and mapping global and regional air quality, water resources, disasters, ecosystems, and name it. The complexity of these data sets and huge archives requires that the agencies that make the data available also provide the tools to easily search and find the appropriate images. And oftentimes they also provide some tools to run a quick analysis and visualization of the data before the end user decides to download the data. So one example is the Advanced Rapid Imaging and Analysis project run by Jet Propulsion Laboratory. And this website basically provides information in almost real time whenever there is an urgent need for that information. So, for example, if there's a natural disaster, for example, urban flooding occurring here in Houston, I believe this is Houston, they will then generate maps that can be used by the end user directly for their application. No? So here we have a map showing what they call a damage proxy map, which indicates areas that are subjected to, land subsidence or are inundated, or show some structural, collapse areas, and derived another information layer that can be derived from this map is a map showing a rezoning of the area where repair or rebuilding should be allowed or maybe should be prohibited. No? So this is basically a derived map from this map here. No? And it's downloadable and accessible by anyone who has a need for that type of information. So they do it on a event-to-event basis. No? Since I talked a lot about radar, I just want to make sure that we know why radar is used not only in arid environments but also in humid environments for flood detection. Now, radar is active sensor. It generates its own radiation, which is microwave, and it sends out a beam of radar pulses, and these pulses, they interact with the the surface, whether it's a forest canopy. So this cartoon here shows you a forest, and so depending on the frequency of the radar, it may only interact with the canopy and then backscatter, or some penetration is possible, and that depends on the frequency. No? And in some cases, L-band, for example, can penetrate the canopy and then provide information about the forest structure. And similarly, this principle works also for penetrating loose and dry sand in arid environments. No? So just make sure that we understand what the sensor is recording. So it sends out the radar signal, and depending on the surface property, this signal may bounce off in the opposite direction, and the sensor will basically not get any return signal, right? Or the surface is sort of rough, and it receives either a diffused backscatter signal, or directly a very direct return signal, and then it can record the strength of the signal and sort of determine what type of surface may have caused this backscatter. And that's what we use for coastal flooding, or any flooding, not only coastal flooding. We look at the radar signal and how it interacts with the surface. And here we have an example of the East Coast in the United States. And this was, this was during the Hurricane Matthew in 2016. So this image shows the situation before the hurricane and then after. And you can see that in green, this area is quite vegetated. And in blue, you see basically smooth surfaces representing the water surface, calm water, no? A very flat, horizontal surface, no major irregularities, except that the forested area shows, of course, a lot of irregularities, and of course, urban areas. After the hurricane hit this coastal area, we see that the backscatter signal changed from the pre-event image. So we see certain areas showing a different backscatter. And that's because those areas are flooded and you have a combination of let's say standing vegetation, and then a water lamina that is very smooth, right? And that will change the backscatter properties. The same with urban areas. You have vertical structures, I mean, houses and buildings, and then the ground is covered by a smooth water laminar, which is the flooded area. And that will sort of generate a different backscatter signal than compared to the situation when the surface was not flooded. All right, and with this, I would like to finish my talk. And here's my email in case you want to contact me. And thank you very much.
Thank you very much, Professor Magali Koch, for comprehensive presentation dealing with water resources, quantity and quality, flood, land use change are the critical problem with the specific case from Egypt. According to Professor Koch, big data from remote sensing can be utilized to monitor water resources and flood, land use change, and ecology. So satellite measurement produce satellite products and dedicated for environmental application. So for those participants who would like to raise question, comment to Professor Koch, kindly invited to write down at the meeting chat, and the dialogue between speaker and presenter has been running. Professor Jel has been nicely responded question raised by the participant. Okay, now allow me to continue with the third speaker, Professor Wiku Adhisasmito, PhD. Operator, could you show his short CV? Yes. Professor Dr. Hewan Wiku Adhisasmito, MSc, PhD. He is lead expert team for National Task Force for COVID-19 mitigation. He is also Indonesian government spokesperson. I think is one of the most popular in Indonesia. Every day he is on TV speaking about the development of pandemic COVID-19. You can see the education. He graduated from Colorado State University for master and PhD, and his undergrad background is in Ibb University. Working experience, you can see, he is professor in health policy, Indohon coordinator, IPR coordinator, adjunct professor at Tufts University, and secretary of board of trustee UI. And his research focuses on infectious disease and global health, One Health policy. I think he is the right person to share his view on how pandemic COVID-19 affect to environment, to energy, and to other aspects that we now join. Professor Wiku, time is yours. Hello, is Professor Wiku there? Can organizing committee, Professor Nanning, to help us to call him to join to present his view for this session, please? Professor Satria is there. Welcome, Professor Satria. Professor Arif.
Thank you, Pak Dato.
Yeah. Prof. Nanning, can you updated information about Professor Wiku? Is he available to present?
Yes. Yes, Professor. He is available, but at the moment have to leave from another meeting. Just
okay.
Yeah.
Yeah.
Yeah. While waiting, probably if anybody have a question, Professor, about.
Okay. Okay. Yes, if everybody have question, comments to Professor Jel and Professor Koch, while we are waiting for Professor Wiku.
Prof. Sudarto.
Oi, Professor Wiku, nice to see you. Welcome to 6 ICENIS, Prof. Wiku.
Thank you.
Are you ready to present, Prof. Wiku?
Yes, yes.
Okay, we already introduced you about your work, your background, and etc. And now time is yours, 30 minutes for you, Prof. Wiku. Please.
Okay, thank you very much. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I'd like to give an honor to the organizing committee, Professor Dr. Tri Ratnaningsih Suprabhawati, MF Science, and the co-chairperson, Dr. Thomas Triadi Putranto. And I'd like to also recognize Professor Peter Gell from the Federation University Australia, and Professor Jerry Miller from Western Carolina University from the US, Professor Fatima Yusuf from the UPM, and Professor Robert Peacock, University of the Free State, South Africa, and Director of the University of Gezira, Sudan, and also Dr. Rahman Vaidyanathan, the University of Sheffield, UK, Professor Arif Satria, and also Dr. Ruanda Agung Sugardiman from the Indonesian Ministry of Environment and Forestry, and Dr. Budi Warsito, the School of Postgraduate Studies of the Universitas Diponegoro. It's an honor to me that I will present about the COVID-19 lessons learned and future preparedness. And I'm sure that the ongoing COVID-19 pandemic is caused by the novel severe acute respiratory syndrome coronavirus 2, where the latest notable disease of to spill over from animal to humans. This phenomena is beyond the zoonotic. We should understand about the situations, and although the direct associations between the pandemic and the environmental damage, such as climate change, remains unclear. Both animals and the environment have a significant role in the emergence of the infections. And conversely, while the world grapple with the COVID-19 pandemic, as humans disrupt nature by deforestation and intensive farming practice, along with the alteration of the human-animal interactions by the international travel and trade, the risk of incidence of the future pandemic is escalating. So with this talk aims to explore those issues concerning the interconnections of animal, human, and environmental health of the COVID-19 pandemic, and the directions in anticipating the next outbreaks. In dealing with these entwined issues, the implementations of the One Health approach is very critical and required. And that I would like to mention about the situations. First is that I'd like to show the video about the coronavirus as a start. Please listen about this one. Okay, if you look at that short video, then we should understand about the national and the global challenges because of the land use change, the global mobility. This is the threat for us in terms of the COVID-19 risk, and also the climate change, the natural disasters, and also the epidemic of the infectious disease. So in looking at this, I like to show the what I call it disease of tomorrow, something that happened which we are unprepared and we don't know, we cannot predict if we don't learn the science behind that. So therefore, we need to have a strong surveillance system to predict what things that will be happening in terms of emerging infectious disease. And if we look at the emerging infectious diseases since this publication published, we can see that there are several diseases that happened and causing a lot of troubles to us. And there are many more that is possible in the future if we don't protect the environment and have the balance of the human-animal environment ecosystems. And if you look at the joint external evaluations indicators back during the Global Health Security Agenda, where the International Health Regulations 2005, that several countries in the world had not been able to really prevent, detect, response of the emerging infectious diseases, where we measured the several indicators, including laboratory systems, the real-time surveillance, workforce development, emergency operation centers, and etc. And if we look at that 9 points of the Global Health Security Agenda, this is related to the COVID-19 situations. And the score average is 3, which is considered okay. But if we look at what happened right now, it's fall apart. It's fall apart, and this is one of the examples. The indicators, the score, and the countries that I'd like to compare, some of them have good score, like 4 demonstrated capacity and 5 sustainable capacity. But if you look at those countries right now, they are suffer from COVID-19. So therefore, that the world were preparing to face with the disease of tomorrow, but finally, what we see right now, it's fall apart, and that's why we need to have the collaborations across countries in the world, and to make sure that the balance and stability of the human-animal environment occur. And if you look at this timeline, you can see one country and to the others are falling apart in terms of the COVID-19. And we need to improve the security or the resilience of the people of those countries to make sure that they can face with these issues. Therefore, the One Health concept that is combining the human, animal, and environmental health works together. Because if it's not, then we're just facing with the disease at the human end, and we don't restore or fix the problems at the animal ecosystems as well as the environment ecosystems into one ecosystem balance. Therefore, we need to work together across sectors. And if we look at the global health core competence, that is important to be equipped to the people who are working in the area of health, at least, or other sectors, is important, which is the management, the communication, and informatics, because the disruptions by COVID-19 is not only disrupting the governance of health or public health, but also others, because economic and social sectors as well. And we need to have the value and ethics, the leadership that can work across sector, across interest, and the team and collaborations within the country, within the region, and also across nations in the world. And we need to take role and responsibilities. For example, when we are dealing about the vaccines, for example, vaccine availability, there are several countries in the world, more than 130 countries do not have access to vaccine at this moment, and we need to help them as well, because this is pandemic and the disease can go across the countries if we don't protect all of the nations in the world. So that's basically the message that I'd like to share. And then when we deal with this such issue, we need to consider about the strategy to make sure that all that we are dealing with in the government is also understood by the people, by the other stakeholders. So that's why the approach of the pentahelix is important. And we need to have a good navigators, which is the data as part of the information that we need to have. And it has to be in one data systems. And of course, right now, there are many people in the world and the government use the data based on the, I would call it casualties, or the human casualties, the number of the people infected, and then death rates, etc. But we don't really measure how the virus is circulating. For example, probably with the whole genome sequencing survey in many different parts of the world, and see what is circulating. And also in the same time, we need to see the risk factor at the human side, whereas the behavior is the key. And if we don't really measure the risk factors at the human behaviors, then we let the virus attack us, and then we calculate the number of the casualties. So therefore, one data system is important, and public health resilience, it has to be improved through the public communications. So therefore, when we fight with this, this is not a fight of the government of each country, but this is the fight of the whole people in the world. And even the effort to map what are the viruses circulating, which probably potentially to attack the human, or because of the imbalance of nature, attack the human. There are several efforts, such as Global Virome projects, that try to collect the viruses in the world and see the potential of this to spill over to the human. And again, not only detecting the viruses that is circulating, but also we need to make sure that the interactions of the human, animal, and environment are in the balance situations. Otherwise, the spillover will occur now or then. So that's why the disease of tomorrow is important to as a wake-up call for us to make sure that with dealing with the COVID-19, that's enough. Only COVID-19. Don't let other diseases to occur with the emerging infectious disease. And of course, we need to strengthen the capacity to detect by having the One Health laboratory networks. And why I said One Health laboratory networks, because this is to connect the laboratory in the human setting as well as the animal settings or authorities, and also environment. If we link all of those laboratories, then we will get the informations if something happen with the emerging infectious agents occur. So I hope that with this speech, I can help and strengthen the united against COVID-19, at least in Indonesia, if it's possible in the region and in the world, because we have to be united. Otherwise, we cannot combat with this pandemic if we just work alone. So thank you very much for your attentions. I hope this inspire you all, and then it will help us to work together combating the COVID-19. Thank you very much. Selamat pagi. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Wiku, for concise, thoughtful presentation. I think the last slide is the message for us. Behavioral change as a key to public health resilience, united against COVID-19. So for those who have questions, comment to Professor Wiku, please kindly write down your question, comments through meeting chat. I hope Professor Wiku is still with us until the end of the program. Thank you, Prof. Wiku. And the next speaker, I would like to cordially invite Professor Arif Satria. Prof. Arif Satria, as all we know, he is rector of Ibb University. He is known a millennial rector. Now he is also chairman of Indonesian Rector Forum, and you can see the history of his position, and then the education background. His undergraduate is from Social Economy, Faculty of Agriculture. This is now called Faculty of Human Ecology, which is he is used to the dean. Master in Ibb and doctor in Kagoshima University in Japan. And there are a lot of experiences in government and public sector. I have not informed the topic that Professor Arif will share, but I would like to kindly invite Prof. Arif to present his view. Prof. Arif, time is yours. 30 minutes from now.
Baik, terima kasih Pak Sudarto. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
The slide is okay?
Yes, we can see.
Yes. Thank you very much. Good afternoon, ladies and gentlemen, Pak Wiku, and all participants, Pak Sudarto. It is an honor and great pleasure for me to attend the conference today, and allow me to introduce myself. I'm Arif Satria from Ibb University, and let me deliver my presentation on mainstreaming sustainability science in natural resource management and SDGs in this very wonderful occasion. Firstly, let me introduce a little bit about Ibb University, and then we will move to the main topic of sustainability science and SDGs, and continued by the study of sustainability and political ecology. Please find the details subsection are shown in the slide. About Ibb University, ranking through the teamwork of our 9 faculties and 3 schools on boosting up our education, research, and devotion to society. In 2020, we are ranked as the best #1 university in Indonesia by the Indonesian Ministry of Education and Culture. We said that there are latest standings of Ibb University in QS, Time Higher Education, and THE Impact, where we are top ranked in 10 SDGs pillars. Now we are going to about sustainability science. There are many articles on the definition of sustainability science. All of them are pointing to the sustainability science is a science that utilizes knowledge for transition towards sustainability, and also the scientific research to develop alternatives that preserve the integrity of ecosystem surface. Ibb said that it can be developed by prioritizing co-creation of knowledge formation through transdisciplinarity approach. Over the past 7 years, the Proceedings of the National Academy of Science of the United States of America has published over 300 papers on its unique section on sustainability science. It confirms that characterization of an emerging field of research identifies its geographical location and contributions disciplines and measures its cohesion as a unified science. It discovers that sustainability science is a very different field structure than foremost science and argues for its unification in an exceptional collaboration network. Agro-Maritime 4.0 is characterized by data-driven analytics, real-time monitoring, and the expansion of sustainability science is needed for the SDGs, Sustainable Development Goals, as SDGs offer an opportunity to align the imperative of climate change action and sustainable development goals at local, national, and global scales. At the same time, defining key challenges for sustainability science in its support of policy. SDGs are the innovative tools for global governance sustainability. Sustainable development has become the core business for Ibb University, and it should be compassed in other education institutions. In academic process, Ibb University since many years has developed curriculum that inform that the importance of sustainability in socio-economy and ecology aspects. There are many subjects in multi-degree have been offered to students. In research, we have encouraged interdiscipline and transdiscipline approach by establishing many research groups and consortiums involving various universities nationally and internationally. Besides, we also actively involve in community development programs to empower and increase communities' prosperity. And Ibb University has implemented some sustainability research programs, center and platform to support sustainability science and SDGs. One of the examples for sustainability research that Ibb currently conducts is Collaborative Research Center 9NO, or effort, collaborating with more than 160 researchers from the University of Göttingen, Tadulako University, and University of Jambi to establish knowledge on ecological and socioeconomic functions and trade-offs in tropical lowlands to protect and enhance ecological function and human welfare. Identifying trade-offs and synergies among ecological and socioeconomic function is a major aim of the interdisciplinary research within CRC 9NO. These are for agricultural land users and associated ecological function in smallholder dominated landscape in Jambi province, Indonesia, about forests, remnant, jungle rubber plantation, and oil palm plantation. We also established a large-scale long-term biodiversity enrichment experiments, BEE, within a monoculture oil palm landscape as a sub-project of the efforts research initiative that investigates the impact of transforming lowland forest into land use system, such as oil palm plantation. We have developed within the context of sustainability a research agenda named Agro-Maritime 4.0 in Ibb Agro-Maritime 4.0. This research agenda is now being implemented in a way that interdisciplinary and transdisciplinary approach are used. As an example, in Agro System Production 4.0, where artificial intelligence, machine learning, robotics, and automation are implemented in different models. And it is smart coastal management, Internet of Things for seagrass ecosystem. And then this is early warning system for coastal community fisher, especially for strong incoming winds. And then microsatellite development for food security, environment monitoring. Also, we have drone artificial intelligence for monitoring biodiversity in palm oil plantations. We have also fire risk system. Fire system provides information about climate fire risk prediction with up to 6 months lead time. The system are combination between weather and so on. And then this IoT-based mini plant factory. It's also SMIP, Smart Mini Plant Factory. And then placing sustainability development as the core business has motivated Ibb University to establish Center for Transdisciplinary and Sustainability Science in 2018 to develop sustainability science to enable producing strategic solutions for complex problems of socioeconomic and ecological issues. The center is expected to contribute to accordance with co-creation and transdisciplinary principles of sustainability science implementation. Our research have contributed to knowledge and science through prominent publication, and some also have produced innovation that have been used by community and industries. CTSS as Study Center has a framework that describes the groundwork for all its activities. The framework consists of sustainability science, co-creations, transdisciplinary research, interest on traditional knowledge, and orientation to SDGs. The 5 frameworks then are referred and applied to one intake, unity to achieve vision and mission set. The sustainability platform Ibb University can be accessed by sustainability.ibb.ac.id, and this platform is made as part of our commitment in achieving SDGs. And contribution of Ibb University in SDGs are apparent due to strong commitment and the core business of Ibb University related to SDGs in developing science and technology in tropical agriculture, ocean, and bioscience. All our sustainability-related documents, such as SDG Network Report, Sustainability Report, Annual Report, and so on. Some other provided documents are SDG Report by every faculties and University Impact Ranks as details. Now we are going to the issue of sustainability and political ecology. Sustainability and political ecology become new perspective in natural resource management analysis. As we know that environmental crisis has an impact on the problem of natural resources, particularly food source, because now we are Indonesia, Global Security Index has ranked 62nd in the world. And then in 2018, Indonesia got a score of on sustainability index, this very critical issues, and as well as if we have the issue of food loss and food waste, because we are now second in the world after Saudi Arabia. There are 2 perspectives to dissect and unravel and understand the source of the environmental and natural resource crisis problems. The first is ecological modernization. The second is political ecology. Ecological modernization is an effort to readapt the industrial community to its environment by using modern science and technology for carrying capacity of nature and sustainable development. And ecological modernization was first used by Joseph Huber, who sparked the greening of industry theory. And Huber emphasized the need to fundamentally improve the environment through a strategy based on innovation and technology to create co-benefits for ecology and the economy. And then in this slide, we are talking about the economy rationality versus ecological rationality. We have to make a balance among them, because ecological modernizations, we talk about ecological rationality that is needed to balance economic rationality. And production and consumption activities can provide economic and ecological benefits. And there are a variety of ecological modernization social movement like Car-Free Day, Earth Hour campaigns, and then anti-plastic bag movement, tumbler usage, and many other movements. And now we are going to another perspective, is political ecology. Political ecology is social and political conditions surrounding the cause, experience, and management of environmental problems. and the field of study to socio-political aspect of environmental management. And environmental issues are inseparable from the political and economic context. We call politicized environment, involving interest actor, like in local level, regional level, and global level. In political ecology, at least there are two dominant approaches. The first is actor approach. The second is critical approach. Actor approach seeing the problem of environmental degradation as a result of power capitalism or state policies that have an impact on local communities and the environment. About the critical approach, it's not crisis approach, it's critical approach. Critical approach starts from the problem of domination of nature. In his book, One Dimensional Man, Marcuse explicitly states that domination over nature is linked to domination among humans. In this critical approach, this approach raises a constructivism approach that environment and natural resources are the result of social construction. The antithesis of environmental positivism about the single interpretation of change. Now we are going to the issue of governance crisis. The crisis of environment and natural resources is crisis of governance. Governance crisis is the failure to regulate the action of state, market, and community actors with interest resources. And then new governance, we need to combine ecological modernisation and political ecology. Ecological modernisation and political ecology are the perspective that we need to use them in looking at the to formulate the new governance. There are three levels: normative level, and the scientific level, and the regulatory level. In normative level, we talk about ecological justice. In scientific technocratic basis, I think constructivism is very, very important to be alternative for positivism approach. And regulatory basis is about inclusiveness and equity of access. The first is normative basis is when we are talking about ecological justice, we have to refer our constitution, Article 33, paragraph 3, mandates that the land and water and natural resources contained therein shall be controlled by the state and used for the greatest prosperity of the people. The state, society, and market society relations must contain the content of justice, critical issues, and ecological issues. And then about the scientific technological basis, it is the basic for new governance, about the issue of constructivism. Like, for example, foresight needs an approach to avoid separation between environmental explanation as ecological rationality and politics, environmental political analysis. It is a very, very important statement from foresight. If it relies too much on political principles, it will not touch biophysical factors, then what will emerge is inaccuracies. And then, if you rely too much on environmental principles, what will emerge is injustice. So, ladies and gentlemen, I think how we make the combinations, hybrids between political principle and environmental principle is very important to make the justice and accuracies. And then transdisciplinary approach with sustainability science that combines local science and knowledge with the principle of inclusiveness and justice also is very important, because we need to recognize local knowledge. It is very, very important in sustainability science. So it is kind of the principle of inclusiveness. The third level is about regulative. In regulative level or regulative basis, the issue of inclusiveness and fairness of access is also very important. So we have to come up with the new approach of governance. We call adaptive network governance. There are at least 5 pillars in this adaptive network governance. The first is the basis of the relationship between actors is trust. Trust is very important. It's as a pillar of relationship among actors. And then the second one is collaborative based management instruments. The third one, the role of state is very, very persuasive. It's not repressive. And then orientation on mutual benefits. And the last one, interaction between actors is characterized by learning and interdependence. Ladies and gentlemen, now we are going to the concluding remarks that sustainability science for SDG implementation needs strong commitment from all stakeholders, and knowledge-based strategies should be developed using inclusive approach. The new governance of natural resource in Indonesia seeks common ground and combines ecological rationality, economic rationality, and moral rationality, as well as political rationality. Now we are coming to the end of my presentation, and I wish success for this conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for thoughtful and inspiring presentation, Prof. Arif. Prof. Arif shared with us about the importance of university to take a policy, program, and activities that contribute to sustainable development and SDGs. And one thing that is interesting, usually people make dichotomy between ecology and economy, but Prof. Arif proposed one motto: political principle need to synergize with ecological principle in order to justice. Okay, if there is a question, comment addressed to Professor Arif, please welcome to write at the meeting chat. And now allow me to continue with the last but not least speaker, Dr. Sitaraman Vaidyanathan. Dr. Sitaraman Vaidyanathan, Senior Lecturer, Associate Professor at the University of Sheffield, United Kingdom. His undergraduate background is from University of Madras, India, Master in Mumbai, India, and PhD in Glasgow, United Kingdom. I think he is now with the University of Sheffield, United Kingdom, and his research of interest focus on bioenergy, metabolomics, mass spectrometry, imaging, microbial, and microalgal biotechnology. Prof. Vaidyanathan, time is yours. Please. Okay. We can see Prof. Naning still make call for Dr. Sitaraman Vaidyanathan.
Good morning to you. Can you hear me?
Oh, yes. Welcome, Dr. Vaidyanathan. Nice to see you.
Yeah, good morning.
Okay.
This is very early in the morning here in the UK.
Oh, yeah.
So it's about 5 o'clock. So I suggest you use my recording. I've given you the recording.
Yes.
Thank you for the kind invite. I'm around to answer questions. So please use my recording and I'll be able to answer the questions that come around, if it is okay. Yeah, because it's too early in the morning here. I don't want to wake everybody up. Good morning to you all. It's a pleasure to join you at this international conference and thank the organizers for giving us an opportunity to share some of our results. I'm going to be talking to you today about microalgal cultivations and the nexus we can establish between water, energy, and environment using these cultivations. So much of the work is being done by primary members of the group, both past and present listed here. They all come from different backgrounds in different countries. For convenience, I'll minimize my screen so that you can see the presentation in full. going forward. So what is shown here is the fourth court, which is central to the University of Sheffield. And it houses 3 of the bioscience departments. And Sheffield itself is in the center of the British Isles. One of the members of the academic community in the past who's been a Nobel laureate is Hans Krebs, famous for discovering the Krebs cycle, as you might have known. I am in the Chemical and Biological Engineering department, which is the Faculty of Engineering. We have a fantastic building here, which is called the Diamond, where we house different departments of engineering. We bring them together in one building for educational purposes, primarily for teaching engineering. It has facilities for students to mingle together and exchange skill sets differently. So my focus is primarily on photoautotrophy, which involves understanding a bit of photosynthesis and fixation of carbon dioxide with the help of sunlight and water. So the reducing equivalents that can be derived from solar radiation and water to fix the carbon dioxide. It also requires supply of nutrients such as nitrogen and phosphorus. So the stoichiometrically, a simple stoichiometric expression of the biomass is shown here. I mean, this could be the algal biomass that is fixed, where the carbon is fixed into. That could serve as a food or nutrient supplement, as an energy vector. So some of the components that could be formed as reduced carbon could act as energy vectors or chemicals of value, so long as we can sustainably source carbon dioxide and the nutrients as well as water in a sustainable manner from the environment. So we see that the plant biomass can fix 114 kilocalories of free energy stored for every mole of carbon dioxide that is fixed. And 1 kilogram of algal biomass stoichiometrically can result in fixation of theoretically 1.9 kilograms of carbon dioxide, resulting in biomass productivities of the order of about 30 to 120 tons per hectare per year, which translates to 50 to 220 tons per hectare per year of carbon dioxide that is fixed. Microalgae are quite versatile and diverse, and this can be seen from their distribution in different lineages, both genetic lineages as well as habitats. So what is shown here are in yellow are the different types of microalgal groups, and in red are the different example species, for example. So you have bacteria on this end where cyanobacteria belong to, and several eukaryotic clades to which different types of microalgae belong. So what it shows effectively is the diversity in terms of the distribution of the genetic distribution of the microalgae and also its habitat. So you can see microalgae present in fresh waters, in marine waters, in brackish waters, and so on and so forth. So it basically indicates high metabolic versatility. Microalgae are a source of ingredients for marketable products currently, and that enables us to use microalgal cultivations to fix the carbon dioxide towards products of value. Now, the challenge is to see if we can use the nexus between water, energy, and environment to develop sustainable bioprocesses and, in fact, a sustainable bioeconomy. So our interest is in primarily focused on carbon dioxide fixation capacity of these organisms. And we've been looking at storage products, primarily lipids and carbohydrates, and ways to maximize their accumulation. So we're interested in understanding how to fix the carbon dioxide as well as to route the products, a better understanding of carbon uptake and routing by microalgae. Can we increase throughput of carbon from carbon dioxide to products of value? Can we utilize the nexus and uncouple growth and accumulation of products for sustainable productivities? Because often growth and accumulation of products are inversely related. So if we can uncouple the growth and accumulation of products, then it enables us to produce more products, so increase productivities. And we have other similar interests. So some of the work that I'm going to be present to today is outlined here. I will go through some of the proteomic data that we have obtained from two primary organisms, Chlamydomonas reinhardti and Phaedaclum tricornutum, and this has been done towards establishing a systems level understanding of metabolic regulation, primarily of oil accumulation in these two organisms. I'll present to you some data to show why cryopreservation temperatures are important to retain functionality. I will also present to you data with respect to optimizing use of carbon, nitrogen, phosphorus, and in our understanding and maximizing the usage of these nutrients with Chlorella vulgaris and Nanochloropsis oceanica, both of which are marine strains. So one is a brackish water estuarine strain, that is Chlorella vulgaris, and the other is an open ocean strain of microalgae. I'll also briefly describe our inlay into biorefineries, establishing biorefinery, for example, with Phaedaclum tricornutum, which is a diatom. So much of our work in the area started with post-genomic characterizations to develop a systems level understanding of oil accumulation and its regulation. So what is shown here is a simplistic representation of the flow of genetic information from genes to metabolites down to phenotype. So genotype starts from here, and the genotype enables the organism to express a particular phenotype. But not all genes are expressed at all times. So only certain genes are transcribed, and some of them are basically translated into proteins, and that responds as a phenotype. So each of those components at these levels can be characterized. So the whole complement of those is what is shown here. So you have the gene complement as the genome, the transcript complement as a transcriptome, and similarly the protein complement as proteome, and then the metabolome. So if we monitor, this is not necessarily, this is a very simplistic representation. Obviously, it's all regulated at different time points, as is shown by these arrows. So not all genes are expressed at all times, and only some are expressed, and that is controlled by these regulations, as an example. So it is quite a complex network of activities, but at any time point, if we want to study the response to a stimulus, the phenotypic response is what we normally see. But if we inquire at these different levels, then we see that at the genetic level for a particular environmental stimulus, the response is not changing much, but at the transcriptome level, there are some changes that could be monitored. And if we take it forward to the proteome and metabolome, that's a bit more dynamic, and there's a lot more changes. So we are more interested at the proteome and metabolome levels, and studying the changes that are happening at these levels, we believe will throw more light on a specific phenotypic response, which is why we are trying to look at the proteome and metabolome level. So we have looked at the proteomic level. The data that I'm presenting here is for two of the publications for two of the microalgae. In both cases, the work presented is to capture the proteomic changes in response to nitrogen limitation, which is a commonly employed strategy to increase lipid accumulations. And what is shown here is a green algae, where lipid accumulation is compared to carbohydrate accumulation. So when you expose the algae to nitrogen limited conditions, this is an exposure to different time points. We see that carbohydrates are produced first, and there is a lag before lipids production starts. So carbohydrate is used as an intermediate storage product. So that is first accumulated, and if the nitrogen limitation continues, then the organism chooses to accumulate lipids and stop carbohydrates, convert that carbon back to, route that to lipid accumulation. So we wanted to study what is happening at the induction of carbohydrate, as well as compare that with induction of lipid accumulation in this organism by looking at the proteome. So each data point here in this graph, each dot represents a protein, and what is shown on the x-axis is the fold change compared to the 0 time point at each time points. And what is shown on this y-axis is the significance of the change. So anything that is in red says that that is 95% significant, so more reliable. So when we compare the proteomic data set from the induction of carbohydrate accumulation to the induction of lipid accumulation, we see that there's a lot more changes that is happening in this organism when lipid accumulation is being inducted. We've also studied this with Phaedroclum trichornotum, which is diatom, and we see that there are more changes that are happening compared to carbohydrate accumulation and lipid accumulation in Chlamydomonas reinhardti, the green algae. So when you compare the two types of algae, Chlamydomonas is a freshwater algae and Phaedroclum trichornotum is the marine diatom, there are unique changes, but also there are similarities. You see that lipid breakdown is decreasing, photosynthetic apparatus is decreasing, translation is reduced. So there are some common elements that can be deciphered, but because of the differences in the type of organism we are looking at, we do also see some unique changes unique to each of those species. So it is not enough to produce algae with functional capacity. It is also important to see if we can retain that functional capacity under cryopreserved conditions. So normally when we are having microalgae under industrial setup, we need to maintain those algae, and we try to maintain them by cryopreservation, which is the recommended protocol. And these cryopreservations are normally done at low temperatures, relatively low temperatures. You could do it -20 degrees in simply available freezers, to -80 degrees, which are specialized freezers, as well as liquid nitrogen temperatures, which is -196 Celsius. So we wanted to see, storing at these different temperatures, does it affect the functionality of the algae? The functionality we were expressing, we were trying to study, was the lipid accumulation capacity of a particular strain that we found to have high capacity to accumulate lipids. So we grew them under nitrogen limiting conditions. So first in phase 1 under nitrogen replete conditions, and then in phase 2 under nitrogen deplete conditions to elicit the lipid accumulation capacity. We then cryopreserved the biomass for 4 months under the 3 different temperatures, and then we grew them again. So we thawed the cryopreserved cultures, and we grew them again under nitrogen deplete conditions to see what the response was, whether the microalgae was able to retain the functionality of producing lipids. So we see that what is shown here is the growth rate for phase 1 for the 3 different conditions, temperature conditions, compared to nitrogen deplete and nitrogen replete conditions. So the nitrogen replete and nitrogen deplete conditions do show a comparable growth under phase 1, because in phase 1 for nitrogen deplete as well, it is a nitrogen deplete. So both of them have the same data point, but then you see that that capacity is only retained for -196 degrees Celsius. So for the cultures that are stored at -15 and 80 degrees Celsius, -80 degrees Celsius, it has lost that capacity to grow. It takes a longer time for acclimatizing. So in the phase 1, it takes a longer lag phase. In phase 2, where the exposure to the nitrogen limiting conditions would show a decrease in specific growth rate, we see that same capacity is shown for -196 degrees, but then that capacity is lost. The cells are able to grow faster than you would expect them to grow under nitrogen deplete conditions, because both of these are nitrogen deplete conditions, but from cells that are stored -15 and -80. And when you look at the protein concentrations, you see that replete conditions, the proteins are growing and the proteins are increasing, but then that is decreasing under all the N deplete conditions. But more importantly, for the lipid accumulation, only the -196 grown cultures stored cultures have retained the capacity to produce lipids. The others seem to have lost it. So this is an important finding in trying to ascertain that only if you store the cultures under liquid nitrogen temperatures, would you be in a position to retain the functionality? Now, nitrogen is a key element. So we studied the difference in response to nitrate and ammonium. So we wanted to see what happens if we replace nitrate, which nitrate is the common nitrogen source that we use to grow these cultures. And if we replace that nitrate with ammonium, which is a reduced form of nitrogen, and increase the light, both of these basically provide the cell with more reducing equivalents that they can use to produce lipids. So do the cells, do the microalgal cells use that reducing equivalent that we have provided to fix them, to fix the carbon dioxide in terms of increased lipids, is what we tried to study. And this we studied with two streptopiles. One is a diatom, P. trichinotum, and the other is Nanochloropsis oceanica. And what is plotted here is electron transfer rate over the PAR, and we see that for all those conditions, nitrogen deplete, replete, and deplete, and ammonia used as substitution for nitrate, as well as ammonia with an inhibitor of nitrate reductase, which is tungsten in place of molybdenum, which is present in the active site of the enzyme. We see that under these conditions, Nanochloropsis oceanica is more broadly accommodative of the different life conditions that P. trichinotum is not. So we used highlight at 1,000 micromoles where P. trichinotum is completely inhibited, whereas Nanochloropsis oceanica is still active. And we see that the photosynthetic efficiency correspondingly is reduced with nitrate deplete conditions as well as the ammonia conditions in P. trichinotum. That is not the case with Nanochloropsis oceanica, because it's capable of accommodating that high temperature and high light intensity. And if you look at the carbon to nitrogen ratio, which is a good proxy for lipid accumulation within the cells, we see that the carbon to nitrogen ratio is increased, as you would expect for nitrogen limited conditions. But then with ammonia, that is not necessarily the case, indicating that the nitrogen is being assimilated and within the cell. So there is no increase in carbon to nitrogen ratio. But how does this translate in terms of fatty acid accumulation, which is what we wanted to study? And we see that that is increased for Phaeodactylum trichinotum. So the nitrogen we supply as ammonia is able to act as a good nitrogen source, and it doesn't necessarily stop the growth of the algae, as would happen under nitrogen limited conditions. So in fact, we are able to increase the lipid accumulation even more than under nitrogen limiting conditions. So the net result is that the high light intensity and ammonia with tungstate enables increased lipid accumulation productivity in the P. trichinotum. And we see that that is not the case for Nanochloropsis oceanica, which shows an opposite trend, indicating that there is difference in behavior between the two strains. We also try to look at that information in terms of physiological response between two different species. So one is Nanochloropsis oceanica, and the other is Chlorella vulgaris, which is a green algae. And we wanted to see if there is the translation of their capacity to accumulate high lipid content, which was noticed under batch culture conditions, to continuous culture conditions, so under continuous output. So we examined oil accumulation, which is shown as the yellow oil droplets, as well as the carbohydrates, which is shown in red droplets here. So both are storage products accumulated. So carbohydrates is accumulated more. Both are accumulated in both the species, but carbohydrates accumulated more in Chlorella vulgaris compared to Nanochloropsis oceanica. And we investigated 4 of the factors: nitrogen and phosphorus supply, which is shown on the X and Y axis here, light intensity, which is color-coded, and the carbon dioxide supply. So the size of these circles indicate carbon dioxide supply. So larger circles indicates larger carbon dioxide, smaller circle indicates smaller amount of carbon dioxide that is supplied. And we looked at 30-odd runs of semi-continuous cultivations for both the species and compared their responses. And we see that N and P concentrations play a significant part in the nitrogen, in the accumulation of oil. And the response of the two organisms differed. So we noticed that there is a downregulation of cell size for both the species to maximize light absorption. So both the species are became smaller in size to enable maximization of light absorption under nitrogen limiting conditions. So as we move from here to from the left to the right, we are going from nitrogen and phosphorus replete conditions to nitrogen and phosphorus depletion. So there is no nitrogen and phosphorus on the right hand side, and there is more nitrogen and phosphorus on the left hand side. We also noticed that the nutrient threshold for these two species differed. So for Nanochlorosis oceanica, it was able to respond to oil accumulation at a lower, even at a lower threshold concentration of nitrate, even before the nitrate was depleted. So the nitrate was not necessarily depleted. So it didn't require the nitrate depletion to occur for oil accumulation to be increased. But whereas for Chlorella vulgaris, it required 2 to 8-fold reduced concentration of nitrate and phosphate. So it waited for nitrate and phosphate to be depleted. And it was also accumulating carbohydrate as an intermediate product before or a lipid could be accumulated. And there was also a tendency for agglomeration, okay, under conditions where which increase the carbohydrate content. We are also interested in looking at understanding carbon availability and carbon dioxide uptake kinetics. So CO2 supply does not necessarily equate to CO2 availability and utilization. And this is defined by not only dissolution of carbon dioxide, but also dissociation, the dissociation equilibrium. So what is shown on the right here is the Jerem plot, which shows the major role for pH, temperature, and salinity in defining the carbon species type that is present at a given time. And gas has to be solvated first into the liquid medium because we usually grow microalgae in suspended cultures in an aqueous medium. So when we supply carbon dioxide, the carbon dioxide gas has to be solubilized. So there is a solubilization equilibrium that is present, and the solubilized carbon dioxide has to be present in a chemical equilibrium in the liquid form before it is available for the algae to take up. So there is a dynamic interplay of chemical and biological equilibrium, which we're trying to study and to establish ways and means in which we can understand carbon uptake by microalgae and develop strategies to maximize that carbon uptake in a way to utilize carbon dioxide for fixing carbon dioxide using microalgae as a means of fixing carbon dioxide. We've also looked at biorefineries, and we are developing an understanding of how to develop biorefineries. And there is an increasing consensus globally towards development of biorefineries as an approach for sustainable algal cultivations for manufacturing. The objective being maximization of a number of products and value additions from a single chassis or run. So what is shown here is the downstream processing options of cell harvest and different options for product recovery that are available, and the options for getting different products. So this is for Fairdeckland tricornatum biorefinery, where the products, there are 6 products here, the omega-3 fatty acids, chrysolaminarin, fucoxanthin, exopolysaccharides, triacylglycerols, and free fatty acids as oil droplets, and how we can extract them either all together or at different strategies for sequential extractions, for example, to enable biorefinery operations. And downstream processing is an important component. So we, for example, discovered the use of a sustainable source of bioflocculant that performs very well compared to other flocculants, other bioflocculants, as well as chemical flocculants, and even at much lower concentrations and in 10 minutes time. So 5 milligrams per liter at 10 minutes time was effective. So it's a very cost-effective source that is shown for publication in this publication. We're also focusing on developing microbial co-cultures, mainly from the point of view that algae cohabit in nature with other microorganisms. And in fact, it's hard to isolate ICENIS cultures from algae. So we're trying to see if we can use this to develop synthetic communities to increase productivities. We are exploring it with impact in several areas, including agriculture, and that is what is shown here. You can develop biofertilizers, biostimulants, and biopesticides, for example, in different spheres using algal cultures along with other microbes. So in conclusion, we show that proteomic data towards system level inquiry could be used to reveal key regulatory nodes for induction of lipid accumulation. So I just showed you some information on proteomic data, not necessarily showing how we could use it to reveal key regulatory nodes, but potentially it could be used to reveal key regulatory nodes. And I've given you data to show why cryopreservation of cultures, the temperatures used for cryopreservations are important to see whether we can retain functionality. We showed that supersaturating light intensity in ammonia can be used as a strategy to improve lipid accumulation in Phaedoculum trichinotum, but this necessarily doesn't work with a similar strimnopile, slightly different species, Nanocropsis, with another strimnopile, which is Nanocropsis oceanica. We've identified key traits to suggesting optimal usage of nitrate and phosphate and differences in response between species. We are currently understanding dynamics between chemical and biological equilibrium to enable carbon uptake to be used as carbon dioxide fixation mechanism. So microalgae to be used as a carbon dioxide fixation tool. I've touched upon biorefineries, downstream processing, and microbial consortia as potential ways forward. And all these have relevance to either food nutrient supplement, energy vector development. For example, carbohydrates accumulated in the algae could be used as a source of feedstock for microbial production of bioethanol and biobutanol. Oil accumulated can be used for biodiesel, and carbohydrate accumulated can also be used for biohydrogen production as well as for biogas production. But it also requires sustainably sourced carbon, nitrogen, and phosphorus from the environment, as well as water for reuse, especially, for example, with the downstream processing. If we can retain the water effectively, we could reuse that water necessarily in not only in microalgae cultivations, but also, for example, in allied spheres like aquaculture. In a Southeast Asian context, or South Asian and Southeast Asian context, we have a vast coastline with potential for sustainable control development of marine microalgae value additions to meet UN SDGs. There is scope for resource reutilization, potentially towards developing effective circular bioeconomy with impact in aquaculture, agriculture, food security, local energy generation, and sustainable chemicals manufacturing. And microalgae can be a potential source of natural diversity to study and develop controlled and monitorable strategies that preserve biodiversity, but also enable a circular bioeconomy to be developed. Finally, I wish to thank all the collaborators, not only at the University of Sheffield, but also at Cambridge University and SAMS in the UK, and also our Indian partners, but more importantly, also the several funders. And importantly, I would like to thank all of you for your patience in listening to the talk. And I'm happy to answer any questions that you might have.
Okay, thank you very much, Dr. Raman Vaidyanathan. Ladies and gentlemen, participants of 6th ICENIS, I think all speakers have presented their ideas, their works, and the dialogue, question and answers through meeting chat has been running. Now I would like to invite all of you to raise question, comments directly, or you can also raise your hand so that I can see. Okay. Okay. While waiting for a participant to raise question, I would like to make a comment and would like to have respond from all of the speaker. Okay, one lesson learned from pandemic COVID-19 is a reflection of how the development has been practiced so far, which prioritize more on economic growth with little attention to environment and social aspect. We frequently heard about the concept of build back better as a type of development which is not only to recover pandemic COVID-19, but also a development that more resilience, more synergized between economic, social, and environment. As the development after COVID-19 event, we have known when the pandemic COVID-19 will be end. So I would like to invite Professor Jel, Professor Mekalog. Prof. Wiku has left the room meeting because he has another commitment. My colleague, Prof. Satria, and Dr. Raman Vaidyanathan. Who is going to first? Prof. Jel, are you still with us?
Yes, I am. I can offer a comment.
Yes, please.
I regularly read some of the papers that we have in Australia, and there has been much commentary that we've been let down with the move towards privatization for the last 30 years. Many service industries have been privatized, and they've been privatized on the justification that private industry is much more efficient than government. However, of course, a director of a company has a legal obligation to maximize profits for shareholders, and they don't have a legal responsibility for serving the community or society. So I think the conversation in Australia, and I suspect also in the US, has been a little bit of a pullback on the long-term push for privatization, and maybe a shift towards moderating that with some more government regulation. And I've made a comment in the chat that we embarked upon a water market to manage water allocation in the Murray-Darling Basin, and that has driven some rather perverse outcomes. People buying water not to use the water to grow food, but to speculate on the price of water. And so when you have an acute water problem, you can't afford people coming into the market and just holding on to water with the view of making money. So I think we've had a little bit of a shift over the last year or two back towards greater regulation and less free market.
Okay. Thank you, Professor Jel. Professor Magaliko, are you still with us? I understand that in Boston right now is close to midnight. When we started 2 hours ago, in Boston is 2 p.m., 10 p.m. Right now, maybe it's about midnight. Professor Koch, are you still with us? Okay, I would like to hear from Professor Arif Satria.
Yes, thank you, Prof. Sudarto. At least we have 4 points to address the issues by Pak Sudarto. The first is COVID-19 pandemic is one of the indication of the problem of environment. I think environmental balance. Now we are dealing with the issue of environmental imbalance. So pandemic COVID, it is also ecological issues. The second one is about regulation. I think regulations to overcome the COVID-19 pandemic should be based on scientific approach. And the decisions, I think the government still have the dilemma how to prioritize economic first or health first. We actually in academic society already developed what we call health economics, how to make hybridize the economics approach and health approach. So I think it is one of the solutions to deal with the issue of pandemic COVID. The third point, I think is very important for us to encourage all of the society in the world to have the strong collaboration. I think it's not the responsibility of the government only, but we need the synergy of the private sector, the community, university, and the other parties. And I think it is the collaboration is the most. The fourth one, I think, is now we are crisis. Well, now we are in the crisis, and every crisis so far, if we look at the history of crisis in the world, like for example in Second World War, I think the crisis, it's political crisis in the world. After crisis, the people come up with the new innovation, like jet machine, radar technology, penicillin, and computer. Innovations, the disruptive innovations come in the crisis. And I think our challenge in the world, how to come up with the new disruptive innovation during the crisis. The last one is about the leadership. I think to overcome the pandemic COVID, and we need to have the strong decision. So we need strong leadership, not only in the central government, but also in provincial and local government. Thank you.
Thank you, Prof. Arif. I would like to invite Dr. Raman.
Yeah, I'm not in public policy, but in the UK, if you see the response, I think the environment obviously globally has benefited in a way from the COVID crisis in minimizing transportation. So the pollution, air pollution part of it, as many of us have seen possibly, as kind of we're giving a breathing space for the environment to recover in some sense. But also there is a requirement for us to learn to live with the crisis of this sort, because obviously it's not a question of choice between either this or that, especially with respect to economy and public health. Both are important. And it's very difficult to choose between the two. So the direction of activities that the UK government is taking, or possibly what is happening within the UK, is to try and incorporate both. So there is always this fight between the two sides, if you like, in terms of where the importance is given. Obviously, the public health is more important only if you're alive. Can you think about economy? So, but at the same time, we cannot shut everything down and for the economy to not prosper. So we need to learn to live together. And that is where we are currently. And that is helped primarily through technology, for example, in maximizing vaccinations. So to try and see if we can and maximize the maximum population to get them to buy into the argument that vaccinations are working, and which on evidence, it seems to be the case, because the number of cases for Delta variants are still going up. They are slightly going on the downward hill. We're past the peak, it looks like, but we never know. So we're just on the top. And but the number of hospitalizations and deaths have come down compared to the first and second wave. So we are currently in the third wave. So in the third wave, you can see the hospitalizations and the deaths have plateaued out a lot more compared to what it was before in terms of the COVID-19. So there is a belief that obviously to suggest there is sufficient evidence to suggest that the vaccinations are working, and it is possible to vaccinate and learn to live with COVID, especially because you cannot shut down the economy. And you need to innovate as well, as the earlier speakers have pointed out. Innovation is very important. And there is a lot of, it's spurred a lot of development. The vaccinations itself in the UK, the discovery of the vaccines, has been speeded up quite rapidly, which is a historic example, because it's not happened in the past as quickly. And normally people predicted a lot more time that will be required for vaccines, effective vaccines, to be developed. But now we see a lot more vaccines that are available, not just one or two, but plenty of types. And these are all quite effective, and they seem to be working. And so I think the bottom line is we have globally got to learn to live with such pandemics, and how fast we adapt to the pandemics is an important important scenario. And it's important to know, if we can, to learn to adapt as quickly as possible to live with it, and not just shut ourselves down, because that's not possible.
Okay. Thank you, Dr. Rahman. In Indonesia, now we are encountering the choice between health and economic growth. And we need to simultaneously run together. Okay, any question, comment from participants? We still have about 25 minutes. We are ahead of time. This is unusual. Usually we are run out of time.
I see
we are all good organizer.
Yes.
Okay. Anyone? Okay.
I see a question there, I think addressed to me. I don't know if I can read
yes.
it.
At the room chat.
Yeah, how to use.
Okay, from Desi. Yes, Desi Susilaning Tias. Hello, Desi. Hi, Desi. Are you still with us, Desi? Desi. Okay, no, she is not there. Okay, if there is no question, I think the response from speaker is something about closing mark. I would like to end this session by conveying my closing remark. Please, operator, to show my short closing remark. So this is a short poem. Rose is beautiful flower. It inspires us to love the nature. Pandemic enforce us to sustainably collaborate together for a brighter and better future. So by closing remark, I would like to end this session. Thank you very much for all speakers for thoughtful and inspiring presentation. And thank you all for participation, for cooperation. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Sudarto Hadi, for leading this plenary session, and Professor Peter Jel, Professor Magali Koch, Professor Wiku Adisasmito, Professor Arif Satria, and Dr. Sitaraman Fadinathan for the extraordinary talk. Okay, next, the ICENIS committee would like to show our gratitude to our keynote speakers through certificates. We are thankful that our honorable speakers take the time to attend and talk in the ICENIS 2021. Here are the certificates for our speakers in the day one ICENIS plenary session. We hope that we can keep the collaborations healthy for greater good. Once again, thank you so much for Professor Peter Jel, Professor Magali Koch, Professor Wiku Adisasmito, Professor Arif Satria, and Dr. Sitaraman Fadianathan. Excellencies and distinguished participants, we would like to remind all of you to please fill in the form to record your presence of the plenary sessions. You can find the link to the form in the chat room.
Thank you very much.
Terima kasih.
Terima kasih.
Yes.
Prof. Arif, terima kasih banyak Prof. Arif.
Terima kasih. Sukses selalu.
Sehat.
Sehat, alhamdulillah.
Stay safe and healthy.
Yes.
Rahman.
All the best. Terima kasih.
Pak Peter, ya, Andis dan kalian semuanya. Salam sehat selalu.
Thank you, Prof. Arif.
Thank you.
Prof. Peter, Prof. Rahman. Thank you.
Prof. Nani, why don't we take a picture?
Yes, I already asked the MC. I think they waiting the time.
Okay.
We are going to take a picture together. So, dear
Yes.
excellencies, please stay, and to all participants, can you please turn on your camera on and give your best smile, because we are going to capture the special moment. Don't forget to turn your background using the ICENIS background, the virtual background. So be prepared because I will capture. Give us your best smile. All right. Stay there. 1, 2, and 3. All right, because I need to slide right. Keep calm. Okay. Stay there. I need to take time. Wait. So many participants here. Okay. 2. Okay. Next. 3 of 10. Yes, give us your best smile. Stay on your camera. All right. Okay. Hang in there. Imagine that it will boost your day, so just smiling. All right. Next. Okay, maybe Candice, you can help me to capture also.
Yes, I will try to capture it.
We got 100 participants here. All right. Yes.
Okay, done?
Yes, we have done. Thank you to all participants, ladies and gentlemen.
Okay.
And thank you.
Thank you.
Thank you. Stay safe and healthy.
Yes. Safe and healthy.
Professor Arif Satria, thank you. And Professor Magali Koch, Professor Hadi.
Thank you.
All right, ladies and gentlemen, we have finished our day one plenary session, and after this, we are going to another main agenda, which is parallel session. I know you have prepared your presentation, your research to present in 6 ICENIS 2021. So we will share the Zoom link or the Zoom ID and the passcode. Yeah. So here is the Zoom ID and the passcode. There are 14 rooms and each one of you can join with the Zoom room where you will present your paper. Yes, you can make a note and then after this, you can directly go to the Zoom link and okay, you can respond my question in the chat. Are you participants have done to capture or note your Zoom link or Zoom ID? Yes, here are the Zoom ID and the passcode for you to enter the room to present your research and your paper. To remind to all of you, don't forget, before you leave the Zoom, please kindly fill the attendance list in the link on the meeting chat. If you still any confusion or any problem, I'm waiting for you to respond on the chat box, but if it's done, okay. For those of you who got on the second day presentation, you can wait for the next link because we still have the day two. We still have other plenary sessions on day two. And on day two, we will share the Zoom link and the passcode too. So you just need to join to the next day on the second day. And for those of you who have finished, you will finish on your presentation on this day. You can still join on the second day of the plenary session. To all participants who still have any confusion, I will inform you later to the committee, so the committee will answer your question clearly. Okay. Excellencies, distinguished guest presenters, ladies and gentlemen, we would like to thank you all for this special occasion. I am Cheha and my partner Gandis would like to say see you tomorrow and break a leg. Have a nice day.
Good luck to every participant. See you tomorrow.
There is additional information for those of you who will present on the second day. You can join to the Zoom on this day, so you can enter the room to watch other presenters present their research, so you may watch it.
Yes,
So
that's
everyone,
right.
good luck. See you tomorrow. Don't forget on the second day. And please remain again the information that we have informed on the meeting chat about the payment registration to present. Please kindly finish that requirement. Thank you all. Yeah. So everyone, good luck. You can join to another room and you may leave if you want to leave this Zoom meeting. Thank you, everyone. See you tomorrow.
Sudah ada acara